Hi everyone, welcome back to the course. Today we are diving into one of the most fascinating topic in JavaScript, how JavaScript actually run behind the scene. We are going to explore the JavaScript engine, execution context, and the mysterious concept of hoisting. This is where things get really interesting because understanding this concept will help you avoid the common bugs and truly understand why JavaScript behaves the way it does. So let's get started. So first, what is JavaScript engine? Right? A JavaScript engine is a program that executes JavaScript code. Okay. The most popular one is V8 engine, which powers Google Chrome and Node.js. Other browser have their own engine, like SpiderMonkey for the Microsoft. SpiderMonkey for Firefox, JavaScriptCore for Safari. The engine does the two main things. First is parsing. Second is execution. Actually, the parsing is it read your code and convert it into something that the computer can understand. Actually, what we write, the script is not understood by our computer, right? Computer only understand the binary code 0 1. So the initial stage JavaScript engine actually converted our code into a computer language. Secondly, execution, and it actually run that code. Okay, here is the simple flow. This is the simple flow. I hope it you could understood what is happening here. Initially your JavaScript code or script, then the engine parse it, then create an initial execution context. After the execution context is created, then execute this code and destroy this flow. Okay, destroy this execution instruct. Okay, so this is the actual flow. Your script, then parse it by engine, then create an execution context, then execute this code. Now let's talk about what happened during the execution phase. An execution context is basically an environment where the JavaScript code is evaluate and execute. Think of it a container that hold all the information needed to run your code. There are two. There are mainly two types of execution contexts are available. One is global execution context. Another is the function execution context. Okay. So what is the global execution context? This global execution context actually does for you. Actually, it's create your JavaScript file fast run. Okay, it's create a global object in the browser. This is the window object, and it set up the memory space for the variables variables and function. And finally, there are only one global execution context. Okay. Second, the functional execution context. Created the wherever a function is called. This function execution context. Each function call get its own execution context, and finally it can have a multiple function execution context. Actually, let me show you an example. You see this function. When this could run, initially global execution context is create. Then it's then when the grid is called, a new function execution context is create for that function. This function. Okay. After the function is finished, after this function is finished, the execution context is destroyed. Okay. So this is the phase. Now, phases of execution context. Actually, now here is the really important part. Every execution context is created in two phases. First is memory creation phase, or you can say initial phase for the creation phase. Second is code execution phase. Okay, so initial phase, I mean the creation phase, there is a few points. Point actually it does. Actually, this JavaScript scan through the code, full all code it scan first, then allocates the memory for variables and functions. Okay, variables are initialized with undefined value. Initially, all variable are when are stored, its initial value will be undefined. Then function are stored entirely in memory. Okay, this is the memory creation phase. Secondly is code execution phase. JavaScript run the code line by line, and JavaScript is a single threaded. Okay, so it's only run at a time, only single execution code, single line of code. Actually, it's run the code line by line, and at a time only one task, not all are together. And variable get their actual values, And thirdly, function are invoked when called. Actually, this is a code execution phase. Initially, JavaScript run all the code line by line, then it's collect the variables with the actual value, then the function are invoked when called. Okay. Actually, let me demonstrate you. You see, if you say undefined here, actually, what do you think? This will output. Actually, maybe you could say undefined. Well, actually, this will give us an error, but we'll come back to that when we talk about the hoisting part. Okay. Let me show you the defined example now. Another example. Just remember this part. This is the another example. This output actually undefined. First, then hello world, because actually initially it's give you the undefined, then you get the hello world. Why? Because of hoisting, and those two phase we are talking about. Okay, we just talk about actually those two phase. Okay, so okay, let's talk about the hoisting. One of the JavaScript most misunderstood concept. So what is hoisting? Hoisting is JavaScript's behavior of moving declarations to the top of their scope during the memory creation phase. But here is the key. Only the declaration is hoisted, not the initialization. Okay? Let me break this down with the variables first. Remember, actually behind the scene, how JavaScript treated this code. Behind the scene. Actually, JavaScript treat this code like this. Declare, we are using the var, right? So initially declare the variable. We know that line by line code, when the JavaScript read, initially it store the variables, and declaration as a hoisted var equal var x, and you are console log this, so it's showing undefined. Then you are storing the x equal 10. So initialization stay here. Then you get your actual value in your console log. Okay, but what happen if using the hoisting with the let and const? Suppose this, now it give you a reference error because you are using the let block scope, and it's give you the cannot access. Why? Before initialization. Okay, so let and const are hoisted, but they are in what we call the temporary dead zone from the start of the block until the declaration is executed. Until this declaration is executed, we call the temporal dead zone. Okay, so you can't access them before their declaration. That's why this is the let and const are block scope. Actually, this is why using the const and let is better. They help you write cleaner, less error-free code. Okay, now the function hoisting. Let's look what how function are hoisted. There is where it get interesting. Maybe think function declaration. You are initializing the you are execute the function before it declare, right? I mean, function declaration are fully hoisted. Remember, this function declaration are fully hoisted, both the name and the body. That's why you can call them before their declaration. Okay, and that's why this it doesn't matter wherever you are calling your function, is it before or after, you get the output, because function are stored first, then it execute. Like function expression. So how it work? Okay, so here the say hi, this function is hoisted as a variable. Okay, hoisted as a variable and initialized with undefined, right? Hoisted as a variable. So when we try to call it, we get an error because undefined is not a function. That's why we get the type error. Say hi is not a function, and this is the function expression. So if we do this with this exactly same thing with the const variable, so how it look like? initially when you are using the var, it's give a type error, say say hi is not function. But when you are using the const, it's give you the reference error, and it say cannot access the grid user before initialization. Okay, so it's more clear and you anyone could understand, right? And this is a cleaner concept. Anyway, what if the arrow function? So you actually get the same thing what you get from the function expression. You also get the same thing with the arrow function. Actually, the arrow function and function expression with the const or let behave the same, right? They are in the temporal dead zone until declaration. Okay, let me show you the complete example that ties everything together. Okay, test it. So let's trace through what happened here. First is memory creation phase, right? Second is execution phase. So first memory creation phase, this A is hoisted and set initially undefined, and you get the undefined. Then calculate function is fully hoisted, and then the multiply is hoisted but in temporary depth zone. This multiply because this is hoisted as a const variable actually, so it's a temporal dead zone initially, this function. Okay, then the execution phase, the line 1 will be A is undefined, and the line 2 the calculate 5, I mean this function line 2, and it's work because actually it works because it's fully hoisted, so return 25. Okay, then the line number 4, this line number 4, this A actually, sorry, this line number 3, first line number 2 and line number 3 is A, and get the value of 10. Then the line number 4 get okay, initially this value will be get 10 and also get the actual value 10. A will be 10, and then the line number 4, 4, it's give you a error, the reference error, cause actually it's still the temporary dead zone because we are calling this function before it's declare, right? That's right. Okay, let me recap again. Initially line number 1, it's give you the undefined. This one means this A, the execution part. Okay, this A initially give you undefined. Then line 2 the calculate, it's already defined, right? It's already hoisted, so we get the actual value without any error. Then this console log is line number 3, and we already have a value, right? We already get the 10, so we easily printed out this 10, and now the A equal is 10, and this output is correct. Then the line number 4, or we can say this 4 console log, it's given reference error because it's now temporarily in dead zone. It's not immediately hosted because we are declaring this function before it sorry, we try to execute this function before it's calling. Okay, so I hope you understood. Now the final section is our the call stack. One more crucial concept, actually, the call stack. This call stack is how JavaScript keeps track of execution context. It's a stack that data structure last in first out, or LIFO method, you can say. So what is it actually? Look at this. The call stack for this code. So initial will be the global execution context is created initially first. Then call this fast function actually is called and push into the stack. Then second, then third, then fourth, and so on. Okay. So when the third is push, then again third will be complete because when these third are pushed to the stack, then these third are complete, right? That means last in first out. So this last one will be complete and its execution context will be destroyed. Then second one, then first one. Okay. So how you get the output and how it's look like? First function, then second function, then third function, then the second function again, then the first function. Okay, this is the actual output. Output look like. So here is something I actually wanted to show, and there is a very wonderful website available for this visualization concept, and it would be helpful for you how this actually work in the browser and how it does. So open your browser and look at this website, JavaScript Visualizer 9000, and this is a very good website and it's really helpful for your understanding. So you see there is a call stack, click this example and then run. You notice something here, there is a did you see all the function are called. Now initially evaluate the script, right, then run task, then if there is a micro task it will run, otherwise it's render. But what is happening here, notice, run this button, you see initially first, notice here, then second, third, fourth, fifth, now so on and 10, right? Now what is happening, we are still in the skip phase, okay, here, then run. Now the last one is out, last in first out, okay, notice now it's the render fully, I mean the execution phase is complete and totally destroy the execution phase after the complete all the call step, okay. So check this website, it's really helpful and you can understand more in visually how it work, how does all the how this engineer work, okay. Okay, great job. Based on what we have learned today, there is some best practice I actually wanted to share with you. So first, always use the const by default. Let when you need to reassign, avoid var, it cause confusion when the hoisting, okay. Second is declare variables at the top of their scope, makes your code more readable and matches what JavaScript does internally. Third, use function declarations when you need hoisting, otherwise prefer arrow function or function expression with const, okay. And fourth is beware of the temporal dead zone, okay. What is actually this, if I just write in temporal, okay, temporal dead zone, okay, this is the temporal dead zone. Don't access variable before declaration, remember, don't access variable before declaration, this is called the temporal dead zone. So all right, let's recap what we covered today. JavaScript engine, the phases and the execution executes your code. Then the execution context, the environment where the code run, global or functional and functional context. And two phases, the memory creation where the hoisting happens and the code execution. Okay, remember, memory creation is the actual place where the hoisting actually happens. Remember, and this is very important question for interview. And secondly, hoisting declaration are moved to the top during the memory creation. Var is initialized with undefined. Let and const are the temporal dead zone. Okay. Function declaration are fully hoisted without any issue. And others last and the final point will be the call stack. The manages execution context in leaf order. Okay. Leaf order. So understanding this concept is crucial because they explain so many JavaScript behaviors that seems weird at first. Now you know what's happening under the hood. I hope so. In the next video, we will explore scope, nested scope, lexical scope, and the scope chain, which builds directly on what we learned today. So thanks for watching. If this helpful, you understand JavaScript better, give it a like, drop your questions in the comments. I will see you in the next one. Bye.